My name is Chris Ramirez. I'm really excited about where the industry is going from a software and a hardware perspective to really enable new engineering workflows. The whole point is to take something that's a precious resource, which are your engineers, and allow them to do more in the time that they have. The key has been that we've always embraced new technology. We've been planning for it before the engineers knew that they needed it, before your companies knew that they needed it, so it's ready whenever you start. More than 20 years ago, we actually created the first workstation back in 1997. 2005, right? We saw what value that having the dual processor solution would for your CPU-bound solutions, and so we brought that to market. In 2008, the first 2U rack, which was great for if you're wanting to move the kind of noise and heat of a typical workstation, into a data center. But when you look at the more recent developments in 2016 and 2018, being ready for the cutting edge for VR and for AI was really what we had been focused on, because we knew the software companies were going that way and that we need to have systems that were ready to run what you wanted to run. And so really what we're seeing in professional computing graphics, your models are getting huge. You're integrating VR into your workflows. You have a lack of simulation experts in the industry, and then adoption of AI tools. You've heard a lot about AI. You've heard a lot about denoising, utilizing AI. There's a lot of other things that will be coming with regards to AI from a generative engineering perspective that will really change how the engineering workflow occurs. So the challenges are getting optimized. No longer today is simply doing topology optimization good enough. You're being challenged, right, to reduce the time it takes you to create your parts. You're being challenged with utilizing new additional manufacturing techniques. You're really, optimizing your products for performance, reliability, and manufacturability. But communicating the design intent has gotten more difficult as your models have gotten larger, as the things that you're putting together have gotten bigger, and you're pushed to make the mistakes early, or to get those kind of things where catch them early. That means you've got to be able to take someone that isn't an engineer and put them into a situation where they can envision, say, the entire aircraft or the entire car. And we found that VR is a perfect way to do that, to communicate design intent. Simulation is one of those areas that traditionally it's been the design engineer throws it over the wall to the simulation expert. And the simulation expert then throws it back after they look at it and says, make these changes here, the changes are made, and you go back and forth. That takes a lot of time. How do we allow the design engineer to actually take part in some of the simulation upfront work so that when they first hand off the model to the simulation expert, it's already 90% there? So we see these trends, we see the problems that you're having. What types of workflows could the ISV and IHV, hardware and software community, introduce for engineers to be able to do their work faster? If we can provide photorealistic rendering and do that in short time, as opposed to having to take overnight for a rendering, that would actually cut a significant portion of your engineering time. Secondly, all right, AI, we've got the power in these new systems to optimize your design. Well, how about if it actually provided some of the designs for you, right? So generative design. You're just defining the bounds, you're defining the forces, and have the system itself come up with 100 different designs that could be useful. Along with that is rendering the denoising aspect, so AI for denoising. And what it allows you to do is be able to create those photorealistic renders that much faster. So again, trying to eliminate the idle time where an engineer presses go and then has to wait for something to render. We feel like the democratization of simulation is something that's critical to the future of the engineering workflow. And this is, how do I have my design engineer take part in the simulation process? Not replacing the simulation engineer, but how do they get the design to be that much better before they ever hand it off? And then 3, VR. So we've already talked a bit about VR from a collaboration perspective at the design review phase. But now we're seeing more of VR being used in the product design phase. Matter of fact, if you come by our booth in the expo, Volke is with us, and they're actually utilizing VR in the design phase, where they can have multiple engineers in multiple areas actively in VR on a combined session, talking to one another, pointing out, I don't like this radius, or I need to do this, or I need to make this change when they're looking at a car. And this is something that VR from a review, I think everyone in here probably already accepts, but from a design perspective, it's something that is certainly going to be making a bigger splash. We looked at the kind of the trends. We looked at the problems that engineers are facing, and we said, all right, what technology could we introduce that would actually cut those down? All right, great. Those are the workflows we can introduce to cut those down. How do we actually deliver those workflows? And so one of the ways we deliver the workflows is through our partnership with NVIDIA and RTX Quadro GPUs. We co-developed the product line for our precision workstations with our friends at NVIDIA after looking at what the workflow needs to get faster. And so whenever you look at the problems that we're trying to address, that's how you end up with these new cores in the RTX Quadro cards. So the RT cores, for instance, right, these accelerate ray tracing. These are what you're going to see in Siemens Ray Trace Studio, where it will be doing ray trace rendering of your product, so you can get more photorealistic rendering immediately. The tensor cores, so these are new to the GPU stack, and this really has to do with the AI aspect. Providing that necessary power, right, to do the artificial intelligence denoising. And in the future, I'm sure you'll see more of the generative design, right, where it's all about artificial intelligence actually prompting the engineer to simply input the requirements and let it come up with a part. The VR acceleration, we talked about the ability to have multiple HMDs, so the headset-mounted devices inside the same session. And so you see that improvement in the RTX Quadro GPUs. And then lastly, just the straight CUDA cores. So you've always seen or have seen the GPU acceleration of various software components, right? So the fact is that while it's not as revolutionary as the RT cores and the tensor cores, simply adding more CUDA cores, it gives you an improvement in performance. The photorealism for predictive design, this is something that's really interesting. So you see this aircraft, and they're able to change inside of Ray Trace Studio the materials and the paint that they've got this aircraft in to understand, all right, what is a silhouette going to look like? The marketing aspect is a huge deal, right? And how something visually looks, the aesthetics are something that matter. And so real-time ray tracing is going to be able to give you photorealistic views of the products that you're designing. Talk a bit about VR. We talked about the utilization of it in the design process. So the ability to explore life-size models, whether it's in a cave-type setting or in an HMD type setting, right? The ability to visualize something that is larger than you could possibly house inside of your small design studio is something that is of tremendous value. And I think most folks will probably understand that. The design reviews, identifying flaws, again, I think most of us understand that. We have some of our customers in the AEC industry, so architecture, engineering, construction, utilizing VR to train new construction workers coming onto the scenes. You can imagine any kind of assembly workers building a new car on an assembly line, putting them in VR to understand what their movements need to be, the ergonomics of how they need to move in order to assemble the car. These are all things you can do inside of VR rather than shut down a line to put a bunch of new hires in to let them learn their job. Let them learn it first in VR. And then lastly, marketing and sales. So we all build things that ultimately end up being sold. And so if you can appeal to the end customer by placing them in the product that they're going to be buying, if it's something large enough, or being able to visualize something, rotate it however they want to in order to examine it, that's a real way to aesthetically please the customer and get them to buy the product. And so you'll certainly see more from a marketing and sales perspective when it comes to VR. The real-time engineering simulation that is out there right now that I'm showing is ANSYS Discovery Live. And this is obviously something that's CAD agnostic, so you can take your Siemens NX models and you can put them into ANSYS for your FEA. But what I'm showing here is actually it being accelerated on a GPU. And in the design phase, so you're not having to go off and send it off to your simulation expert. So you can take your design, make a change in real time inside of NX, export it out to ANSYS Discovery Live, and actually see what the change is going to be through whether it's fluid dynamics or really any of the other multi-physics models that ADL supports. And I really do feel like this is the future when it comes to allowing your design engineers to help revise their designs utilizing simulation before you hand it off to your simulation expert. And so really you talk about the benefits, right? It is frequent design iterations. So you're able to go through multiple design iterations as the designer without taking up the simulation expert's time and really focusing on the design tool rather than utilizing it as a verification tool. So you're still going to need the full simulation workup, whatever your tool happens to be, at the end of your design. But this is kind of an interstitial democratization of simulation. I'm going to talk a bit about artificial intelligence. So this was the fourth pillar. Those of you all who aren't familiar with product design, generative design, the future of generative design is unbelievable from my perspective, right? Being able to just say, this is the part that I need, these are the constraints, go, and get 100 designs come out to you, be able to state, okay, what if I only have these materials available, or what if I only have these types of manufacturing available to me? I can't do additive manufacturing, I can only do casting, or I can't do casting, but I have a 3-axis or a 6-axis CNC machine. Right? You take all those variables and put that into a product and it's able to come up and design the part is something that is the future. It's just going to change what the design engineer is having to do on a day-to-day basis. And so, again, it's about reducing the cost, reducing the development time, reducing the material consumption, and of course, our old favorite, lightweighting the part. On top of that, I will show a little bit, so Siemens, the Topology Optimization in their generative design, they're talking about mimicking nature's natural approach. So this is Siemens acknowledging that this is the future of part manufacturing. You can see the part on the right, that's multiple pieces, and then the part on the left was able to be a generative design, likely using additive manufacturing for it to be one piece, one part that gets produced. And so taking a look to see where NX is moving in this area is something that's going to be very interesting in the short term, but ultimately change the work that we do in the long term. And the intelligent performance is actually what I wanted to get to. There's actually things that we do inside of Dell Precision Workstation that makes it unique in the industry. So Dell Precision Optimizer is a software tool that we include with every Dell Precision Workstation. And it actually utilizes AI to optimize the settings on your workstation to give you maximum performance within whatever work that is that you're doing. So if you can imagine, not every engineer is an IT expert to be able to go up and set up their system to have maximum performance. So how do you know how to actually set your system up for maximum performance? Well, it depends on the software you're using. Some software is CPU bound, some software is GPU bound, some software likes a single core as fast as it can go, some software will utilize multiple cores. So what we've done is created Dell Precision Optimizer to actually see how the user is using their workstation, make the automatic changes on the fly to maximize the performance of the engineer and the application. And so that leads to the improved reliability. It is centrally managed, so your IT person is able to see what's being put down on the workstation, apply it to other engineers within the organization. So if you have one engineer that's absolutely top-notch, who you want to mimic, you're able to take their settings and put that on the other engineers' workstations. Conversely, if you have engineers that have been given more horsepower than they're using, right, you'd be able to see, wow, this person looks like they haven't used anywhere near the same amount of RAM that they need, but they've been maxing out the storage subsystem. Perhaps next time we should modify that configuration for that system. So that is Dell Precision Optimizer. It is unique to Dell, and I'd love to talk about it more if you come by our booth.